In this video, we're going to take a look at the relationship between probability and z-score. Earlier in the semester, we looked at the empirical rule. And to refresh your memory, the empirical rule said that 68% of the data was going to lie plus or minus one standard deviation from the mean. If you look at the bell on the chart that you're facing, you'll see that plus one standard deviation is 34% and minus one standard deviation is 34%. Or the 68% of the demand occurs plus or minus one standard deviation. Looking at the rest of the graphic, you can see that another 27%, bringing the total to 95, is plus or minus two standard deviations, and virtually 100% of the data falls plus or minus three standard deviations. Keeping this in mind, let's take a look at the worksheet that follows. On this sheet, you can see the same graphic that you just looked at, but in addition, underneath it, there's data on the empirical rule that we just talked about. 68% of the data plus or minus one standard deviation, 95 plus or minus two standard deviations, and 99.7 or virtually 100% plus or minus three standard deviations. And so now we're going to look at how this translates to data that we can use to calculate with functions in Excel. The first one, the square that's highlighted, is converting probability to z-score. And you'll notice next to probability on the left, I have put in 95%. And so if we want to calculate the z-score for 95% probability, we're going to use the syntax that is shown there. Equals, and then we're going to type NOR, start typing normal SINV, standing for the inverse of normal SDIST is normal SINV, and it's going to appear on the drop-down menu on the top left, and we're going to select norm SINV, last item that's there, and it asks us for the probability. And the probability that we're going to enter is the 95% that we've chosen to explore to see what that is. And once we're happy that the entry is right, we're going to select the green check alongside the menu bar, and it's going to return the z-score of 1.64485. That's telling us at a 95% probability it occurs at a z-score of 1.64485. Let's look at the next one, z-score to probability. When we look at z-score to probability, we're given a z-score of 2 and told to use the function NormSdist. And when we start to enter that, again, our drop-down menu, second from the bottom, says NormSdist, and it asks us for the z-score. In this case, we're going to enter 2. When we're happy that's what we want, we're going to select, and we're given 0.97725 is the z-score at the probability at a z-score of 2. Next, we're asked to calculate the z-score of any particular number. Well, we have a mean of 20. Let's calculate a couple of different z-scores. The first one we're going to calculate is less than 20. Let's take the number 18. I'm going to put that in so you'll remember it. 18. And once we have 18, we are told to use the function standardize. And so we'll start typing standardize. When it turns up in the function menu, we'll select it, and it asks us for 3 pieces of information. First, the 18, that's the number we want the z-score for. Second, it'll ask us for the mean, and the mean is 20. And lastly, it's going to ask us for the standard deviation, which in this case we have as 1. When we're happy that those entries are okay, we go ahead and we complete the entry, and what do we show? We show, at this point, -2. -2 is a z-score, and it's right to be negative because any number that we would have chosen that's less than the mean will have a negative z-score. Let's take one that's higher. Let's say in this case we'll use the number 24. Now we're going to use the same function, equals standardize. We'll select it from the menu, and we'll provide the information that it asks for. First, the number that we're interested, 24. Then we're going to go ahead and enter the mean, which is 20. And then we're going to take the standard deviation, which in this case is 1. When we hit enter, we're going to get a z-score for that one of 4. We're going to get it 4, and guess what? 24 is 4 standard deviations away from the mean because our standard deviation was only 1. And so the calculations that we got using these 3 functions are accurate. And there is a great use outside the classroom for these 3 functions. Probability to z-score, z-score to probability, and just the ability to calculate the z-score for any number in a data set. So these functions, the 3 of them that we've just looked at, in conjunction with the previous one of just plain old normal distribution, gives you a really strong arsenal of statistical ammunition that you can use to calculate any number of things outside the classroom.